You and I earlier were talking about heterogeneous integration assembly, system in package, wafer level packaging, panel level packaging. There's a lot of confusion about the terms within this, and we talked about how complicated it is to address that.
Yeah.
Is there a way that we can talk about about what the different packages are, how they function, and basically what the different terms mean?
Okay. I think I myself is confused too at certain gray areas, right? So to me, it's the whole big heterogeneous integration. Yeah, so it can include the SiP, the system in package, and some of the wafer level packaging. It can be fan out sealed, or it can be other kind of, so long as you have different functions die that is being put together, either in a substrate form or whatever form, and then encapsulate together, become a package that has certain function, then we call it a heterogeneous integration or the SiP. And even sometimes you have SiP with the encapsulated and SiP without the encapsulation. So I think it's a very huge space, and all this is actually falls under the heterogeneous integration. Yeah, that's what I think. I don't have a very clear kind of segregation, like which is what.
Is it useful, perhaps, in terms of reliability to differentiate between system and package and these other forms of integration?
I think it depends on the application, where the final package is going to end up in. In automotive, of course, you have a more stringent kind of reliability requirements, but in terms of like if it's being used in a mobile or just your tablets or IoT, you may not need that kind of reliability that the automotive industry is asking for.
And it's becoming important to have co-design of both the thinned, maybe large die, along with the package, so the die and the package are no longer separately regarded, they have to be co-designed.
Yeah, working together. Yeah, so because it's important to have the co-design so that it can work seamlessly together, even though they are kind of heterogeneous, right? So but they need to work together and form a single package, so that is really important for the co-design thing.
And the system in package allows, it's considered a single unit of commerce. For example, you're a cell phone manufacturer, you mentioned an automotive manufacturer, and you're trying to bring in a functionality in a particular pad set out, that rather than bringing all the components together and putting them down on the circuit board, you simply have a simple electrical pad layout, and then you just say to the suppliers, hey, we need you to provide a package that looks like this, and it's this size, this thickness, that does this. And so you're actually, rather than specifying separate components to do that, you're actually specifying the functionality, and I think that's an increasingly important aspect of certainly cell phone manufacture and integration.
Yeah, I think certainly the cell phone industry is driving one of this area. They need to pack as many components into the cell phone as much as possible to have increased functionalities and saving power at the same time, and have a reasonable amount of reliability. All this, yeah, I think, yeah, that is why you have all this falling into place.
Okay, thank you.
Welcome.
If you have any more questions, feel free to contact us. And again, Sze Pei, it's been a pleasure as always.
Thank you.